Two examples of graphing linear equations. When looking at a linear equation, you should see an equation with just two variables and both of degree 1, meaning that they are both to the first power. We usually want to get y by itself so that we can get this in slope-intercept form. In this equation, we have negative 4y minus 8 equals 3x. So to get y by itself, I'm first going to add 8 to both sides. Doing this will eliminate the 8 since we have negative 8 plus 8 is 0, which leaves me with negative 4y equals 3x plus 8. The negative 4 is being multiplied to the y, so to undo that multiplication, we're going to divide every term by negative 4. Since negative 4 divided by negative 4 is 1, we have 1y, and negative 3/4 x. 8 divided by negative 4 is negative 2. So our equation ends up y equals negative 3/4 x minus 2. In that, we see a slope that's negative 3/4 and a y-intercept of negative 2. This is called slope-intercept form. You may have seen this before where it looks like y equals mx plus b. M is always the slope and b is our y-intercept. Now to graph a line like this, I'm going to start at the y-intercept of negative 2. So on the y-axis, we're going to plot our point at 0, negative 2. And then we'll use our slope. The slope is negative 3/4. A lot of times this is taught as rise over run. If we rise negative, we're really just going down 3, but we're going to run to the right 4. So I always go to the right, whether it's positive or negative slope. I'm going to go up or down and then to the right direction. So down 3 and then right 4. 1, 2, 3, 4. I have a point here at 4, negative 5. And I can continue that slope of negative 3/4. So down 3, right 4. If I go further, I'm going to go off the grid. So I can go backwards. In that case, I would be going up 3, and left 4. 1, 2, 3, 4. Gives me a point at negative 4, 1. And we can continue that pattern. 1, 2, 3. Left. 1, 2, 3, 4. So we see this line start to form, and then we just draw in the actual line. So this makes our linear equation, and I always just double check that it is going the direction that we wanted it to go. We had a negative slope, so it's going downhill, and it goes to that y-intercept of negative 2. And there's our equation. For this second equation, we have 3 equals y minus 3x. We still want to get y by itself so that it's in slope-intercept form. This time I'm going to add 3x to both sides. Which does get y by itself. I have on the left side now 3x plus 3. We cannot combine those because they're not like terms. But the y is currently isolated by itself. You can write this on the left side, so it's y equals 3x plus 3. And we see that the slope is 3. And the y-intercept is also 3. If you have a slope of 3, what that would mean is 3 over 1. It is just an integer, but even though we don't see a fraction, doesn't mean that it doesn't have a denominator. So this denominator is 1. We're going to start our line at positive 3 on the y-axis for 0, 3. And then use the slope. Our slope is positive 3 over 1. So we're going to rise 3, 1, 2, 3, and run 1 to the right. Rise 3 and run to the right 1. We can see that those points are starting to go uphill, which is correct. We needed a positive slope. I can also go backwards, going down 3 and left 1. Down 3 and left 1. If we continue that pattern, we can find all the points possible on this line that fit on this grid. And usually the more points you graph, the easier it is to actually make your line. So there's our linear equation. Each time you just want to solve your equation for y and collect all of your variables and combine like terms. Then you'll start to see the slope and the y-intercept.